The typical two-dimensional array is sometimes referred to as a rectangular array because it's a grid, a matrix, a table, always the same number of elements in every row. And many languages have simplified syntax to create a multi-dimensional array that is a uniform size. For example, 5 rows with 6 columns each, allowing you to think about it that way and using the two numbers just to get to each element in this uniform grid. But this isn't our only option. Imagine that we're writing an application for some local tourist attraction. So we're going to have a two-dimensional array, an array of arrays, representing the number of tickets sold for every day in every month. So the first dimension, 0 through 11, will represent January through December. And inside each of those, we will have another array for each day in that month. So we begin with January, which has 31 days. We need 31 elements, so it's 0 through 30. Then February comes along, but it only has 28 or sometimes 29 days, so if we keep the array at a uniform size, we will have 3 unused elements. March has 31, April only has 30, etc., etc. Now, it's certainly possible that you could represent this information with a two-dimensional rectangular array, so where every month always has 31 elements, either leaving the irrelevant elements empty or setting them to 0 or -99 or some other value that you can then respond to in the logic of your program. But that's not always desirable. Well, first, it should offend your programming sensibilities that there are these elements that represent impossibilities like February the 30th and April the 31st. But it is more than just programmer aesthetics. Because if I'm writing code to figure out average ticket sales for any month, I should be able to just grab a row of data, take all the elements in that row, add them all up and divide by the number of elements, without having to then add logic to figure out how many elements I should be ignoring depending on what index we're at and what year we're in. So for this, and many other situations like this, you might actually want an array of arrays where the internal arrays have different lengths. So this isn't a rectangular array anymore. This would be referred to as a jagged array for reasons that should be obvious. We have an array of arrays of different lengths. Whereas many languages do have that simplified syntax to create a rectangular multidimensional array, creating jagged arrays often takes a little more programming work up front to create the structure, because you typically need logic, I'm showing here just as pseudocode, to construct those internal arrays independently because they are of different sizes. It's usually worth the work because then the data structure itself is coherent and it has integrity to it. And this is kind of a theme we will see repeated with the more complex data structures. But what we're doing is choosing to do a little more work up front to create a data structure with internal integrity instead of having to add a bunch of logic later on to deal with one that doesn't.